Hello, I am Shuikta Shekhar Mondal. I am a final year student of Bachelor of Technology in Mechanical Engineering at Heritage Institute of Technology. Uh, my research interests lie in the fields of uh, welding technology, automotive engineering, fluid power control, production engineering, material handling, and robotics. So today I will be talking to you about design and material selection for a hybrid vehicle. I will keep my discussion to be like as simple as possible for so that people who are not engineers can also understand. These are the topics I will be taking you through today. The abstract. So I'll be talking to you about the basic design and fabrication procedures that we undertook for making our very own hybrid vehicle, and a brief idea of what alternate materials that could have been used instead of the materials that we used in our car. The best practice materials. I will give you a big introduction to the best best practice materials that that can be used in a vehicle. So let's start off by defining what a hybrid vehicle is. An hybrid vehicle is any vehicle which has two or more power sources. And the most common one that we see is the gasoline electric hybrid vehicle. In this type of vehicle, a gasoline engine runs along with the electric battery powered motor. So there are two power sources. That's how it goes. So an example can be a moped of a hybrid vehicle. That's the simplest example because it combines the pedal power of the rider along with the battery power. So and the basic idea of the better our design of the vehicle, the more aerodynamically better the design is, the more streamlined the design is, the less is the drag, and thus the lesser is the energy consumed to propel the car forward. And we have to use as light materials as possible because if we use light materials, the overall weight of the car will be less, and so there will be less power required to move the car. That's the basic idea. So the third point is just a fact. Hybrid vehicles consume 30% less energy and releases 30% less carbon compared to non-hybrids. I got this data from a documentary called Cars in the Future. That's about it. The working of a hybrid vehicle. So the electric motor is basically powered by the battery that is housed in the chassis, and the engine is either fueled by gasoline or by diesel. Either one is possible. But in the vehicle that we used, that we made, it has it only had a battery powered electric motor and a gasoline fuel engine. So, and both the power sources transmitted power independently. I will talk more about that in the later slides. The battery can be charged by the engine through belt routing system, you have a route, you attach a belt to the crankshaft, and you rotate a alternator and then store the energy from the alternator, or electrical energy from the alternator into your batteries. So that can be done, and cars can also be recharged through regenerative braking. But in the car that we made, it did not have any way that we did not charge. We did not have any system that could recharge our batteries in the car that we made, but that can be incorporated in higher models, or when we have like higher budgets. So this is basically the CAD design that we developed in the CAD software. The software that we used is SolidWorks. This is a chassis, pretty much it. That's pretty much it. Then after we formed the chassis, we modeled some other parts, like from the top most left corner, it is the bearing, and to it's the ball bearing. The topmost left corner is a ball bearing, and to its right is the suspension, and to its right is the A-arm. And if we go in the second row, the second row, the left corner, it is the trailing arm, and in the right corner, it's a sprocket. So these are the part documents that we designed, and we in the following slide I will show you another SolidWorks file where we have assembled all the part documents. These are only a few of the part documents that we made, but there are way more than what I am showing here because of lack of time. So this is basically the assembly document that we made. You can clearly see the green colored boxes are the batteries. The red portion is the seat for the driver. And then if you look closely you can also see the motor of the car and the engine and the fuel tank. Everything is like assembled here. And if you see the front portion of the car, the car body is designed in a way so that it is streamlined and produces as less drag as possible, thus saving energy. So now I will tell you about the fabrication procedures. For fabrication, we first developed a PVC model. We have a model of the space frame chassis with PVC pipes, so that we can realize the model, and we can actually visualize the models. So that was the reason for making the model. So then we cut ERW pipes into calculated dimensions using circular saws, and we made the grooves using a grinding machine. Then we used the manual metal arc welding technique to weld the steel pipes together and form the space frame chassis. Then we also cut pieces of metal, of steel, and made the mountings for the suspension and suspension, engine, motor, and the wheels. The wheels were of course housed with a bearing, a ball bearing. We used the Ackermann geometry because firstly, Ackermann geometry has a major advantage over Davies steering, because Davies steering uses sliding joints, which causes wear, but Ackermann steering overcomes this problem as it uses revolute pairs which can be easily lubricated and thus causing lesser wear. And we use the multiple disc wet clutches, multiple disc wet clutches comprises of two sets of discs. The first set is connected to the driven component via a spline, and they tend to move in an axial direction along the spline sleeve. 4 bolts pass through the holes in the second set of discs, which can move in an axial direction because of the clearance fit between the holes and the bolt. The power is transmitted from the second set of discs to the first set by means of friction. Clutches, this type of clutches are immersed in engine oil for cooling purposes, and hence they are called the wet clutches. So that's basically it. So this is the final assembly. This is not the final assembly. We made a couple of other modifications after, but this is basically it. You can see in the rear shaft there are 2 sprockets. The first, from the left one, is for the motor, and the right sprocket is for the engine. So this is what I meant, that both the electric motor and the gasoline power engine transmitted power independently. This is what I meant. Like there are 2 different set of sprockets for each power source. In the front wheel, you can see like there we have the independent suspension system, but in the rear wheel we have dependent suspension system. And in the front you can also see the steering system and the master cylinder, which contains the brake fluid. That's pretty much it. The A-arms in the front wheels also houses the ball bearing for holding the tires together. That's pretty much it, I guess. Now the material selection. I mentioned earlier that the lighter materials that you use, the better it is, because it requires less power to move the car forward. To move the car forward. Alloy steel ERW pipes were used. The speciality of steel is that it is made of, it is made of dislocations. There are dislocations inside the steel crystal. So these dislocations can move, and they can absorb energy, and they can change the shape of the steel. And when a car is in the accident, it can absorb the shock and protect the passengers. So that's basically it. Other than steel, glass fiber can also be used as a car body material, but glass fiber has a major drawback. For it cannot be used in countries like India or any other country which experiences rain, because glass fiber is damaged by water. So that's a major setback. Other than this, carbon fiber can also be used as car body material, but the main problem with carbon fiber is carbon fiber is really expensive. So steel with less than 0.1% carbon with up to 0.4% manganese is used as car body material. That's an accepted material. That's a standard material that is used to make car bodies in the current industry. We made the shaft housing out of cast iron. There are a couple of reasons for it, but most importantly, a cast iron is like really cheap, and cast iron is really cheap, and it has a high compressive strength. It is really heat resistant and has negligible shrinkage. Suspensions were made out of low percentage alloy steels. Suspensions are subjected to fatigue and high stresses. So alloy steel is just the perfect material for suspensions. The gears were made of EN9 or EN24 steel. The flywheel was made of, the flywheel is generally made of cast iron, but the best practice material is graphite fiber reinforced polymer. And the ball bearings were made of stainless steel. Everybody uses stainless steel for making ball bearings. So that's about it. Other than that, the cylinder bore is made of aluminium. That's because aluminium is really light, and the pistons in the cylinders are made of aluminium alloy. The carburetor is made of zinc, cast iron, and aluminium. That's about it. This is the final car, our very own hybrid vehicle that we made. So I also already demonstrated, I already identified most of the parts, but I still included this slide because this is the final. This is with all the modifications we made, because we didn't use any car body material. It's practically empty. Only we stitched a few cardboards. That's what we did. Future scope. The future scope of the hybrid vehicles are the future. I can safely say hybrid vehicles are pretty much the future of the automobile industry, because hybridization can be regarded as a significant step in reducing greenhouse effect and harmful emissions. In the modern era, where gasoline-powered engines are ruling the automotive industry, the technology of hybrid vehicles can reduce the consumption of fuel and become one of the most important eco-friendly technology in the near future. Other than this, there are some certain modifications that we can make in a hybrid vehicle, like we can install solar panels or solar cells in the framework of a hybrid vehicle, so we can like charge the batteries from solar power itself. And we can modify the engine so that we can use Atkinson cycle, because it improves fuel economy. Other than that, cellulosic ethanol, which is made from corn, is being increased. It's actually still in experimental stages, but they are using it in the US. It's an alternative to gasoline. It is a kind of biofuel. And the plug-in hybrids. Plug-in hybrids are like you can charge the car, batteries that run the motor from wall sockets. You can charge your batteries from wall sockets. That's like a huge, comfort. It's of huge convenience to a person who uses a hybrid vehicle. You don't have to charge your cars on a regular basis. You don't have to change your battery. So and electric cars, we have the Tesla Motors. There's a company called Tesla Motors. They have developed cars which completely run on electricity. However, these cars are really expensive for a for a average Joe to buy, I guess. And there are hydrogen fuel cells are also being increasingly used. They are not being increasingly used. They are used in Iceland to power buses. Iceland is a really it has a really low population, and they can afford to experiment with these hydrogen fuel cells. Sorry. Hydrogen is basic in this. The principle of hydrogen fuel cells is the hydrogen which is abundant in the atmosphere. This hydrogen is broken apart to form electrons, and this electricity, these electrons produce the electricity that move the buses or vehicles, or whatever. And the only emission from the hydrogen fuel cells is water vapor. So that's like a huge what you call it, advancement in the field of energy environment friendly vehicles, I guess. And of course they emit less harmful emissions because you are going off gasoline and into the electricity grid. And there are a lot of ways you can produce electricity, like geothermal energy, solar energy, there are the hydel energy, hydroelectricity, or like wind energy. There are a lot of ways you can generate electricity. And of course it increases your overall efficiency of your car, improves fuel economy and overall. So the conclusions. Material selection and design, that is the aerodynamic design, play a very vital role in the power consumption. I mean, like, the better your material selection, the better your aerodynamic design, the less power is consumed. And the second point says reducing friction in combustion engines can increase engine efficiency. That's because 50% of the energy in the is lost in the combustion chamber, overcoming the friction. So there is an automobile lab in MIT. They are trying to improve this, increase efficiency of the engine by reducing this friction by lubricating it. It's still in research stage. Plug-in hybrid vehicles reduce greenhouse gas emissions by 40%. So this means when we use electricity from power plants, we are going off gasoline, and I have mentioned this earlier. We go off gasoline and we cut off the tailpipe emissions into the smokestack. But the thing is, like, from today's there has been a survey. I got this 40% data. This data of reducing greenhouse gas emissions by 40% from the same documentary, the Cars of the Future, I think that's the name. I mentioned it in the reference. So the thing is, like, when we use electricity from today's mix of power plants, we actually reduce greenhouse emissions by 40%. That's the basic thing. Hybrid vehicles can also get the same pickup as a regular car, but burns less fuel. This is just a fact. It's the same fact. So that's about it. Now I'm going to show you the video of my very own car that we made. That's our car. It ran, it worked. That's what makes me happy. It's not too much. So the acknowledgements. I have to work with a couple of organizations to bring about this project, because this is a really expensive project. The organizations were Imperial Society of Innovative Engineers and my WBUT. And there are a couple of professors from my tech institute who helped me bring out this report kind of thing, like the paper that I'm going to publish. So I will also include my paper in the description section after I published it. These are basically the references that I used to make this presentation. These are the basic ones. There are a lot more. I didn't show all of them here. This is me presenting the same paper at National Conference on Recent Advances in Science and Technology 2016. It was organized by Heritage Institute of Technology. Thank you for bearing with me with my... So yeah, if you have any questions, you can leave them in the comment section. I will try my best to answer them. Thank you.